So today we'll be looking at physical sciences 2025, and this is it's a workbook that is taken from Stanmore Physics, and this is the chemistry revision book. So today we'll be looking at nomenclatures. So we'll be looking at organic chemistry. So yeah, let's get into it. So in today's outline, we'll be looking at what is organic chemistry, the main objective of studying organic chemistry, and studying organic molecules, their structures, their homologous series, their general formulas, their molecular formulas, their functional group, and their IUPAC names. So buckle up and let's get into it. So let us try to understand what is organic chemistry. Organic chemistry is basically the study of the chemistry of carbon compounds. And we already know that the element carbon is found on the periodic table, and also it's also the element number 6 on the periodic table. So actually 6 in the carbon element actually tells us that carbon has 6 number of electrons. And we're going to draw the first shell. The first shell is filled by 2 electrons, the second shell is filled by 8. But this time we only have 6 electrons in a carbon element. So in this case, carbon will actually have 4 valence electrons or 4 outer electrons. So as we can see from this simulation, that carbon has 4 valence electrons that are ready to pair. So in this case, we'll just try pairing this carbon element or this carbon atom with hydrogen atom. So we already know that hydrogen has only 1 electron or only 1 valence electron. So we'll pair this valence electron with one of the valence electrons from hydrogen, so another one, and then we can see that now we have 2 valence electrons that are also ready to pair. So we can try putting another hydrogen there just to fill it up. And remember that for this carbon to be filled, it has to be filled with 8 number of electrons. If you can pair each electron with 1 electron from hydrogen, we can actually find 8 number of electrons paired. So in grade 12, we'll be using lines to show the paired electrons. Okay, let us try to understand what are organic molecules. Organic molecules are molecules that consist of carbon atoms. This is actually an example of an organic molecule or an organic compound because it consists of a carbon atom and 4 hydrogen atoms. Let us take a look at IUPAC. IUPAC actually means International Union of Pure and Applied Chemistry. And this is a system of naming compounds. So it's a developed standard of naming chemical compounds and elements. So writing IUPAC names of organic compounds. Step 1, suffix. So we have to determine the functional group or the homologous series of the organic molecule. So firstly, let us define what is homologous series. A homologous series is a series of organic compounds that can be described by the same general formula and have also the same functional group. So examples of homologous series are alkanes, alkenes, and alkynes, and these are hydrocarbons as shown on the table, and haloalkanes, aldehydes, ketones, esters, alcohol, and carboxylic acids. And the table that follows definitely shows the functional groups of each homologous series. Now let's define what is a functional group. A functional group is a group of atoms that determines the chemical and physical properties of a group of organic compounds. So let us firstly focus on hydrocarbons. So let us firstly define what are hydrocarbons, and then the three types of hydrocarbons, which are alkanes, alkenes, and alkynes. So basically, hydrocarbons are organic compounds that only consist of carbon atoms and hydrogen atoms. So remember, in the start of this video, I mentioned that each line represents a bond. So between carbon and carbon, in alkanes we have only one line, so this shows that it's only a single bond. In alkenes we have two lines, this shows that we have double bonds. And in alkynes we have triple bonds, this shows that this is shown by the three lines. Step number 2, parent name or parent chain. So in the parent name of parent chain, we will be counting the number of carbon. If we have one carbon, the parent name is meth. If we have 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, and 8 oct. And the parent chain is mostly the longest chain. Okay, now let us recap everything that we did. We already know that carbon has 4 valence electrons, and then each line that is shown here actually represents the paired electrons, so the number of bonds in the paired electrons. We can see that between the two carbon atoms there are 3 pair of electrons, which means that we have a triple bond here, which is actually shown by the 3 lines.
This are called alkynes.
Now we can see that between the carbon atoms, we can see that we have 2 pair of electrons, meaning we have 2 bonds between the carbon atoms. This implies double bonds, which are shown with 2 lines. Now here we can see that between the carbon atom and the other carbon atom, there is only 1 pair of electrons. This implies that there is only 1 bond between the carbon atom, and these are called alkanes. And we'll also be looking at parent chains. If the parent chain has 1 carbon, it's meth, 2 carbon, eth, 3 carbons, prop, and then 5 carbon, pent, 4 carbon, but, 6 carbon, hex, 8 carbon, oct. So the numbers there actually tells us how many carbons are there, the number of carbons in the parent chain. So we have to choose the longest chain and determine the number of carbons in the longest chain. Hence, we know that organic molecules are molecules that consist of carbon atoms. So most of the time we'll be looking at carbon atoms. So remember, for single bonds, we know that it actually represents the number of bonds. We have only 1 pair of electrons, so hence these are called alkanes. For double bonds they are called alkenes, and for triple bonds they are called alkynes. Hence we know that alkanes, alkenes, and alkynes are our homologous series, and the structures on the left hand side actually represents their functional groups. Let us just take a look at what is a structural formula. Unlike functional groups, structural formulas consist of hydrogen atoms surrounding each carbon. So remember, each carbon consists of 4 bonds. In this case, each hydrogen will be filled where there is no bond. So for this alkane, its molecular formula will be given by C2H6. And then we can see from this diagram that we have 6 hydrogen surrounding each carbon. And the general formulas of alkanes are given by CnH2n plus 2. Now, let us take a look at alkenes. A structural formula of an alkene is represented by this structure, whereby it's shown by the H's surrounding each carbon atom. And don't confuse yourself. Structural formulas have H's surrounding the carbon atom, whereas functional groups don't have H's surrounding the functional groups. Surrounding the carbon atom. Don't get confused, please. And the general formula of alkenes is represented by CnH2n, whereby n represents the number of carbon. If now in this case we have two number of carbons, we'll just substitute, whether it's n, we'll just put a 2, and then you'll find C2H4 as our molecular formula. Now, let's take a look at alkenes. Alkenes are hydrocarbons that consist of triple bonds between carbon-carbon atoms. So let's look at this structural formula. This structural formula consists of two carbons, so we have to find its molecular formula, its general formula. So the general formula of alkenes is given as CnH2n minus 1, minus 2. In this case, when we need to find the molecular formula, we only have to just substitute 2, where there is n, since we have two carbons, giving us C2H2. Now let's recap. Homologous series is a series of organic molecules that has the same molecular formula and the same functional group. So we already know that a functional group, we already know the difference between what is a functional group and a structural formula. Hence, a structural formula, it's a structure of a certain organic compound. So now let's consider an organic compound with two carbons, and it's an hydrocarbon, hence an alkane. So in its functional group on the left hand side, we can see that these are two different structures. And we can see from the table that alkanes consist of a general formula written as CnH2n plus 2, and then we can see that functional groups are different from structural formulas. As we can see that we're given an example of a structural formula there and its functional group on top there. Same thing applies to alkenes. We have different functional group is actually different from its structural formula as circled. Same thing applies to alkynes and alkynes. As you can see, alkynes consist of a triple bond, and their structural formulas are actually very different from the functional group. I want you guys to not actually make a mistake. Whenever they say draw a functional group, please do not draw a structural formula, because they are quite confusing, and I want you guys to focus on not making such mistakes of drawing a functional group, whereas they are asking for a structural formula in the question. Please make sure you focus there. So in this question, we're supposed to write down the IUPAC name of the following organic compound. So we can see that the parent chain has 3 carbons, meaning it is prop. Hence, in this case, prop has 3 carbons. And then by looking at the homologous series of this organic compound, we can see that this organic compound is an alkane. In this case, propane, since alkane has a suffix ane. And then we can see that it has a branch in carbon number 2, and this branch has only 1 carbon, meaning methyl, and then hence this implies that the IUPAC name of this compound will be written as 2-methyl propane. Question number 2, we are supposed to write down the IUPAC name of compound A. By looking at compound A, we can see that it's a double bond, so it's an alkene, And then we have to find the parent chain. The parent chain, we can see that we start where the double bond is, which is 1, 2, and 3. Now we can see that it has 3 carbon atom, meaning prop. And then we already know that the homologous series of this is actually an alkene, and it has one branch in carbon number 2 written as 2-methyl. So its homologous series is an alkene, and then we know that prop in. So its full name will then be 2-methyl propene. In this question, we have to find the IUPAC name of this alkyne. It's an alkyne, and then we have 5 carbon, which is pent, and then we have a branch in carbon number 4, which is 4-methyl pentine. So before we go any further, let's try and understand what are halogens. Halogens are found on the periodic table. As you can see on the periodic table, it's fluorine, chlorine, iodine, bromine. So in this concept, we'll be looking at haloalkanes, but we have to start with understanding what are halogens. Halogens are found, or they are grouped under group number 7. And then let us just take a look at chlorine. Chlorine on the periodic table, it's element number 17, so it has 17 number of electrons. So we'll start by drawing the valence shells, and then the first shell is filled by 2 electrons, the second shell is filled by 8 number of electrons, and then when you count them, they are 10, so we're left with 7, so we have to draw the other 7 electrons. And when we count the number of electrons, we can see that chlorine has 17 number of electrons. So looking at the valence shell, the outer electrons of chlorine has only just 7 valence electrons, and then it's missing only 1 electrons. As we can see that halogens are only grouped under group number 7. So this implies, and from this we can conclude that all halogens have 7 valence electrons, and this implies that all of them are only missing 1 electron for them to be filled. As we can see from chlorine has only 1 missing electron in the valence shell. So the number of valence shell of halogens are 7, so that's why they are all grouped on group number 7, as we can see from the periodic table, and there's only 1 missing electron. And let's take a look at this example. This is an alkane, as you can see, and then we already know that chlorine has 1 missing electron, and we can see that this carbon atom is missing also 1 electron, and then we can pair that missing electron with chlorine. Since we already know that carbon has 4 valence electrons, so carbon is on group number 4, as you can see from the periodic table, and carbon is ready to pair 4 times. As we already know that chlorine is missing only 1 electron, so it can pair 4 times around carbon. So if there was no hydrogen there, chlorine was going to pair with carbon, and then if there was no hydrogen below and also on top, chlorine was also going to pair, since, well, it's capable of pairing once, but carbon is capable of pairing 4 times. And we also know that chlorine is an anion, so it's missing only 1 electron, hence shown by the -1, unlike hydrogen, which is shown by H+. So in this case, chlorine is an anion if it gains that missing electron, and hydrogen is a cation if it gains that missing electron. Since it has 1 valence electron, it also has 1 missing electron for its valence shell to be full, since it also has to be filled with only just 2 electrons in it. That's why when hydrogen and chlorine combine, they form a very strong acid called hydrochloric acid because of the strong bond that occurred between the two elements. Now back to haloalkanes. We're going to draw the functional group of haloalkanes, whereby the carbon atom is paired with X that represents any halogen found in the periodic table. So X can represent chlorine, fluorine, iodine, or bromine. Now looking at the structural formulas, the structural formulas actually represents the structure of any homologous series. So the structure, now we can just draw any structure. So whenever you are asked to draw a structural formula, you just draw the structure of a certain organic compound. Hence in this case, and we can see that the functional group has no H's and X that represents the halogens, whereas the structural formula actually shows everything as shown in compound A. As we can see from this, X represents the halogens, whereas in the structural formulas, the halogens are actually there as chlorine and bromine. So the structural formula shows everything, whereas the functional group shows only the lines without the hydrogen atoms. So just to play around, I'm just going to draw a structural formula representing the difference between a structural formula and a functional group. So a structural formula actually shows the H's, whereas the functional group doesn't show the H's, whereas X represents any halogen that can be there in the organic compound. And I want us to examine something here. There's a difference between haloalkanes, haloalkenes, and haloalkynes. So haloalkanes have single bonds, haloalkenes have double bonds, and haloalkynes have triple bonds. So the homologous series for this structure for compound A, it's basically haloalkanes, since, well, it doesn't have any double bond or triple bonds between the carbon atoms. Now let's take a look at the general formula of haloalkanes. So the general formula of haloalkanes is given by the formula CnH2n plus 1x, whereby x represents the halogens such as chlorine, fluorine, bromine, or iodine. Let's say that from compound A, we are supposed to determine the molecular formula for this structure. So basically, the molecular formula is quite simple. You have to count the number of carbons. In this case, we have 4 carbons, 7 number of hydrogens, 2 chlorines, and 1 bromine, given by the formula C4H7BrCl2. So let us take a look at what is the condensed molecular formula and what is the condensed structural formula. So before we go there, just take a look at the difference between what is a molecular formula and condensed structural formula. So now, I want you to be careful and note the difference between the two. So let's jump straight ahead into condensed molecular formulas and condensed structural formulas. In the circled carbon, we know that in that carbon we have only 2 hydrogen and 1 bromine. So we'll just start by drawing the center carbon, and then remember we have C and 2 carbon, which is H2 and Br. Looking at the right hand side of the center carbon, so we have C and 2 H's, and Cl. And the branch part, which is below, we have C and 3 carbons, which is CH3. So this is a condensed structural formula for this compound A. Now we are going to look at the condensed molecular formula for this structure. So first things first, we have to look at the branch. The branch part is CH3. And every time when you're writing the molecular formula, we write the branch inside the brackets as CH3 in this case, and the left hand side as CH3Br. And don't forget the top part, which is Cl. So the right hand side in this case will be CH2Cl. Hence, this is our condensed molecular formula. So most of the time, don't forget to write the branch inside the brackets to show that this is our branch. Now, let's take a look at haloalkenes. Now, as you can see from the structure, alkenes have a double bond. So, whenever we're looking at haloalkenes, make sure that haloalkenes always have a double bond, because they consist of a halogen. It's an alkene that consists of a halogen. In this case, this organic compound is a haloalkene because it consists of a halogen chloride. Now let's take a look at these questions. Let's look at the first question. The first question says, write down the IUPAC name of the above compound. Question number 2, we are supposed to draw the structural and molecular formula of the above compound. Question number 3, what is the meaning of the term homologous series? And what is the homologous series of the above compound? Question number 4, we are supposed to draw the condensed structural formula for the compound and write down its condensed molecular formula. So I want you to pause the video and try this question out on your own. So for this work, we're just going to use the students' solutions, and also answer the question by marking the student's work. So the first question, we're supposed to write down the IUPAC name of the above compound. So we have to choose the longest chain. First step, find the longest chain. So we can eventually tell that the blue chain doesn't actually fit. The only chain that fits is the one that has the double bond and the halogen. So we can see that the halogen, chlorine, and the alkene, we can eventually count from the double bond to the halogen, giving us 3 carbon atoms. In this case, prop. Since, well, if we have 3 carbon atoms, it's prop. And then because of the double bond, we'll mention the suffix "in", since, well, it's an alkene. And the halogen is found on carbon number 3. And so it's going to be 3-chloropropene. And mind you, we still have the branch. We still have the branch that is found on carbon number 2, which is 2-methyl 3-chloropropene. Question 2, we are supposed to draw the structural formula and the molecular formula of the above compound. Whereas the structural formula, it's actually the structure that is already given there. So that's the basic part. Now we have to draw its molecular formula. Write down the molecular formula. So the molecular formula for the above compound, it's C4H7Cl. Since, well, the molecular formula, we have to count the number of C's and H's. So in this case, we have 4 C's, 7 H's, and 1Cl. Now, defining what is a homologous series. A homologous series is a series of organic compounds with the same molecular formula and the same functional group. So, it's a series of organic molecules that is the same functional group and the same molecular formula. So, writing down the the homologous series of the above compound is a haloalkene. So the final question, we are supposed to draw the condensed structural formula and write down its condensed molecular formula. So starting with the condensed structural formula, we'll start with the middle carbon atom, which is C, with a double bond on the left and a single bond on the right and below. So on the left hand side, we have C with 2 H's. Below we have C, H, 2, Cl. And on the right hand side, we have C with 3 H's, which will be written as CH3. Now let's check the student solution. The CH3 on the right hand side is actually correct, and the one on the left hand side is also correct, but the one below is wrong, so the whole structure is wrong. Now we have to write down the condensed structure. Since we know that CH3 is our branch, as circled in purple, so we can put it inside the brackets as open bracket CH3. And then on the left hand side of the bracket, we already see that we're having CH2. And then on the right hand side of the bracket, we'll be having CH2Cl. And mind you, we still have the middle carbon, which is shown in blue on the structure, which has to be written next to the branch, before the branch actually, because it actually joins the branch. So let's try and understand. CH2 has to be there, and the one in green is the middle carbon, and the branch in blue, which is CH3.